Welcome back to Tech Talk, everyone. Today, we're diving deep into a fascinating research paper that explores how reinforcement learning is being used to revolutionize ride sharing. Joining me is Ben, one of the lead researchers on the project, and Maria, an industry expert in transportation technology. Ben, could you tell us about the paper's central focus?
Thanks for having me, Sarah. Our paper focuses on a major challenge for ride-sharing platforms, effectively matching drivers and riders in real time. This is a complex problem because demand fluctuates constantly and driver availability varies significantly across time and location. We developed a new approach based on reinforcement learning to address these challenges.
Intriguing. Maria, could you provide some context for our listeners? Why is this matching problem so crucial for ride sharing platforms? It's absolutely critical, Sarah. Think about it. Ride sharing platforms depend on quickly connecting riders with drivers. If the matching system isn't efficient, riders end up waiting for long periods, drivers may have to take longer routes, and the whole platform becomes less reliable and appealing. This directly impacts user satisfaction and ultimately the platform's success. That makes sense. Ben, let's get into the meat of your research. Could you walk us through the challenges that traditional matching algorithms face?
Sure. One common approach is batch matching, where the system gathers a batch of rider requests and available drivers at regular intervals and then tries to find the best matches. This can be more efficient than just assigning the closest driver to each rider, but it still has limitations. For example, if a driver is available and close to a rider who requests a trip, but that driver is also likely to be needed in another area soon, a traditional batch algorithm might not make the best long-term decision. This is often called the wild goose chase phenomenon, where drivers get caught in inefficient loops of picking up riders far from where they are most needed.
I can see how that would be a real headache for drivers and the platform. So, how does reinforcement learning come into play here?
That's where our innovation lies. Reinforcement learning, RL, is essentially a way for a machine to learn by trial and error, like how a child learns to ride a bike. The algorithm, or agent, interacts with the real-world environment, in our case, the ride-sharing platform, and makes decisions. Based on the results of these decisions, it receives rewards or penalties. The goal is to learn the optimal strategy or policy for maximizing rewards in the long run.
That's a great analogy. So, how is the RL algorithm learning in this case? What kind of rewards is it receiving?
The key is to estimate the value of a driver at any given time and location. This driver value function represents how much money a driver is likely to earn in the coming hours if they continue driving for Lyft, taking into account future demand and their position in the city. The algorithm learns by observing real-time data, driver positions, rider requests, trip fares, and updating the driver value function based on the outcome of its matching decisions.
That's fascinating. So, the algorithm is essentially predicting how much a driver is likely to earn in the future, which helps it decide who to match with which rider.
Exactly, Sarah. It's not just about the immediate reward of a single trip. The algorithm considers the long-term impact of a driver's position on their future earnings. This forward-looking perspective is key to making more efficient matching decisions.
Maria, how does this approach compare to other methods in the field?
This is groundbreaking, Sarah. Previous approaches to RL and ride sharing have typically been offline, meaning the algorithm learns from a large data set of historical data and then applies that knowledge online. Ben and his team have successfully implemented an online RL system that learns and adapts in real time, making it far more responsive to the dynamic nature of ride sharing.
So, it's essentially a constantly learning and evolving algorithm that's adapting to changes in the market as they happen.
Yes, exactly. That's why this approach is so significant. It's not just a static algorithm, it's truly intelligent, responding to the ever-changing demands of the platform.
This is really intriguing. Ben, what were the key results of your experiment?
The results were very encouraging, Sarah. We saw a significant reduction in the number of times a rider couldn't find a driver, which is a major frustration for users, a decrease in rider cancellations, and an increase in 5-star ratings, indicating higher rider satisfaction. On the driver side, the algorithm helped unlock more earning opportunities, resulting in millions of additional rides and over $30 million in annualized incremental revenue for Lyft.
Wow, those are impressive results. Maria, what are the broader implications for the ride sharing industry?
This research highlights the potential of AI for transforming the efficiency and effectiveness of ride sharing platforms. It shows that by incorporating intelligent algorithms that can learn and adapt in real time, we can improve user experience, boost driver earnings, and create a more sustainable and thriving marketplace for everyone involved.
It's amazing to see how AI can address such complex challenges and deliver tangible benefits. But as with any cutting edge technology, there are bound to be limitations. Ben, could you shed light on any of the challenges you encountered in implementing this RL system?
Absolutely. While RL holds great promise, it's not a magic bullet. One of the main challenges was making sure the algorithm was robust and reliable enough to handle the massive scale of Lyft's operations. We also had to simplify some aspects of the real-world system to make it manageable for the algorithm. And of course, there's always the need for extensive engineering and testing to ensure everything works smoothly in a production environment.
So there's still a lot of work to be done in fine tuning and optimizing the system. Ben, what are the next steps for your research?
We're excited to continue exploring the possibilities of online RL in ride sharing. We're looking into how to incorporate more complex features of the real-world system, like different ride types, dynamic pricing, and driver preferences. We're also investigating how to make the algorithm even more efficient and scalable. The potential here is vast, and we're eager to push the boundaries of what's possible.
Maria, what are your thoughts on the future directions of this research?
I believe the future of ride sharing lies in intelligent systems that can learn and adapt in real time. This paper is a major step in that direction. I'm particularly excited to see how RL can be applied to other aspects of the ride sharing ecosystem, like dynamic pricing, driver incentives, and even the development of autonomous vehicle fleets. The possibilities are truly endless.
This has been a truly insightful discussion, Ben and Maria. I think our listeners have gained a deeper understanding of the potential of reinforcement learning to revolutionize the way we get around. Ben, could you leave us with your key takeaways?
This research demonstrates the viability of online RL for solving complex, real-world problems. We've shown that it can significantly improve efficiency, user experience, and revenue for ride-sharing platforms. While there are challenges to overcome, the benefits of this approach are undeniable. We believe online RL has the potential to drive significant innovation across industries, and we're excited to continue exploring its possibilities.
Thank you so much, Ben and Maria, for sharing your expertise with us. This has been a fascinating and thought-provoking conversation. Until next time, keep exploring the future of technology with Tech Talk.